Good afternoon. Welcome to the second hearing of the subcommittee. And today we're going to focus on the challenges and the opportunities for human space exploration beyond low Earth orbit. Human space exploration. We want to get back in that business. It's vital to our space program. It's vital to the science community. It pushes America's best and brightest to the limits of their creativity, and all of us on Earth benefit from it. The allure of exploration keeps our students in science, technology, engineering, mathematics. Just look what the Apollo program did, creating a whole generation of young scientists and engineers and mathematicians. And of course, it helps our country in our leadership in aerospace, basic research, and other high technology areas. So in the authorization bill from 2.5 years ago, we required NASA, quote, to expand permanent human presence beyond low Earth orbit, end of quote, calling on the agency to explore beyond LEO for the first time since the 1972 Apollo 17 mission, beyond low Earth orbit. Under the guidance of that authorization bill, NASA has been working with the nation's space industry to sustain a human presence on board the International Space Station. It is designated as a national laboratory, one component of it. And with NASA's guidance, one U.S. commercial company has already delivered cargo to the station, and just this past Sunday, another commercial company successfully tested its new rocket, and that rocket will deliver cargo to the station later on. Efforts to enable commercial crew delivery capabilities are also well underway, and we look forward to those successes. And so NASA sits at the nexus of the public and private space sectors, and these partnerships enhance what we can accomplish in space. For exploration beyond low Earth orbit, LEO, NASA is currently building and testing hardware for the new Space Launch System and the Orion crew capsule. These technologies will carry our astronauts further into space than ever before. In 2014, a test of Orion will fly the capsule 15 times higher than the ISS before returning it to Earth at speeds near those that General Stafford, who is one of our participants today, reached in his re-entry in the Apollo 10 mission. And that Orion capsule is now undergoing final construction in the O&C building at the Kennedy Space Center. Its heat shield, the largest ever built, is on its way from Massachusetts. And following this test, the heavy lift rocket and the capsule will fly together for the first time in 2017, and then carry its first crew in 2021. NASA is also preparing its people and infrastructure to support this space exploration, to ensure that future missions have adequate ground support. Of course, what they're going through is the upgrades of all of the ground support equipment and launch infrastructure. And those will enable us in NASA, the military, and also the operations in the commercial space sector. So where do we go with these capabilities? Mars is the goal. With the right technology, SLS and Orion will be able to enable a wide range of human missions and destinations, which described going back to the authorization bill include, quote, the surface of the moon and near-Earth asteroids, end of quote. 2 weeks ago, NASA announced its plan to capture a small asteroid and redirect it to a stable orbit around the moon. And the concept is still being studied, but if NASA can find a suitable asteroid and redirect it with a robotic mission in time, our astronauts could visit and study the asteroid during a 2021 SLS Orion flight. And so we're going to hear about that today. Research is also underway to better prepare astronauts for the dangers of exploration beyond low Earth orbit. The Johnson Space Center in Texas, the hometown of this subcommittee's ranking member, Senator Cruz, houses NASA's Human Research Program. Many who have traveled into space participate in an annual physical at the Johnson Space Center. NASA is going to continue to learn about the effects of microgravity on the body when an American and a Russian start their one-year stay on board the International Space Station. We're learning a lot about the effects of zero-G and bone loss as a result of zero-G. We're going to learn at the Johnson Space Center all of the effects that we possibly can on radiation on the human body and how to protect us when we are going all the way to Mars, and what are the kinds of shields that we have to have in case there is a solar explosion on the way to those planets, or in fact, if we're on a moon base, what do we have to protect human life? So NASA's exploration efforts are strong and they're well underway. And there are a lot of challenges, particularly in this fiscal climate that we find ourselves. But with the leadership that we've seen, with the creativity, with the dedicated contractor force and the civil service workforce, then we would have reason to believe that NASA can achieve the goals. And so I want to welcome our witnesses here. I want to thank them. This is going to be an exciting topic to discuss. Our first witness is NASA's Associate Administrator for Human Exploration and Operations, Bill Gerstenmaier. And he's going to give us an update on SLS and Orion and on the technology needed for this human exploration, and on this gee-whiz asteroid mission. Then, of course, we're very fortunate to have someone who is not a stranger to this subcommittee, and he is our Air Force retired Lieutenant General Tom Stafford. Went down and orbited the moon on Apollo 10, and of course, one of the great thaws in the Cold War occurred high above the Earth in 1975 when a Soviet crew joined up with an American crew, and they lived together in space for 9 days in the midst of the Cold War. General Stafford was the commander of that mission. And who better to discuss the value of international partnerships, especially in human space exploration than the man who has been there and seen it since its inception. And of course, in his position, when he left the astronaut office, went back in the Air Force, he was the Deputy Chief of Staff for Research, Development, and Acquisition, and was involved in the initiation of a stealth fighter. He wrote the initial specifications for the B-2 stealth bomber. He knows technology. And then we have Mr. Steve Cook, the Director of Space Technologies for Dynetics. He's going to address NASA's partnerships with industry, the roles of government and private sector together in human exploration, as well as the policy needs. And so thank you all for being here. Senator Cruz.
Thank you, Mr. Chairman, for calling this hearing today on the path of human space exploration. Thank you to each of our distinguished panel members for joining us this morning. I appreciate the opportunity to stand side by side on this vital national priority, and the opportunity today to hear from this distinguished panel on your wisdom and insight and your years of experience on space policy, in particular addressing NASA's long-term mission and any challenges that are presented to that mission by the path we're on today. I also look forward to hearing further about how the commercial sector is making an important contribution to achieving these goals, and how we can further expand that partnership, including perhaps learning lessons about how government can be more efficient and how our space program can continue to generate opportunities for commercialization that generates economic growth and jobs throughout the private sector. It's critical that the United States ensure its continued leadership in space, and that will require broad support from a range of stakeholders, from the general public to the U.S. government to the scientific community. And I look forward to this opportunity to learn from each of our distinguished panel members here today. Thank you.
And we want to welcome in the audience a number of people that are attending the Suppliers Conference of the SLS Orion Suppliers. And so let's start with you, Mr. Gerstenmaier. We'll go right down the table, and then we'll get into some questions after all of you have testified. Your formal remarks are inserted in the record, and if you would share with us verbally a shortened version. Thank you.
Thank you very much for asking me to represent the NASA team for this hearing on challenges and opportunities for human spaceflight. This is a very good time for human spaceflight. The International Space Station is making tremendous progress in space-based research. The ISS is beginning to show its potential as a world-class research facility. Many of the early findings have direct application for people on the Earth. Expedition 34's patch had the statement, "Off the Earth, for the Earth." This statement captures well one of the reasons for ISS. There are several Earth science payloads scheduled to fly in the next year as a direct application of that expedition statement. The recent results from the alpha magnetic spectrometer are also providing unique data on the potential for dark matter in the universe. The alpha magnetic spectrometer is also providing unique data on the cosmic background radiation environment of space. This data will be critical as we send humans beyond the protection of Earth's magnetic fields. Lastly, the Center for Advancement of Science in Space cases is beginning to find real interest in space-based research from a variety of new users. ISS is doing great things. Commercial cargo is proceeding well, with SpaceX having completed 2 cargo missions to the ISS. The next space station mission will carry an externally mounted optical communications package and an Earth-viewing high-definition camera also mounted on the outside of ISS. Orbital just completed a test flight of the Antares rocket from Wallops on Sunday. This was a tremendous accomplishment, both for the vehicle and the launch pad. Orbital will next fly a demonstration mission to the ISS in June or early July. U.S. companies are stepping up to the task of keeping the International Space Station resupplied. Commercial Crew is making tremendous progress in implementing the acquisition strategy and vehicle designs. The draft RFP for the certification and demonstration flight should be out in the next 2 months. All of these efforts complement the use of ISS in demonstrating the commercial value of space. The Heavy Lift Launch Vehicle, SLS, and Orion are also making tremendous progress. The SLS design is maturing, welding equipment is being assembled in New Orleans, and by the end of this year, all major weld schedules will be completed for the core stage. The goal is to begin manufacturing next year in New Orleans. The Orion capsule is in Florida being outfitted and tested for its test flight next year. The heat shield, as you said, was in Boston, having thermal protection material installed. This test flight will provide critical entry performance data for the heat shield. It's really exciting to see a flight vehicle being assembled and outfitted in Florida again. Finally, work is beginning on the B-2 test stand at Stennis. This stand will test the core stage propulsion systems in late 2016 prior to shipping the core stage to KSC for flight in 2017. The work on the service module with the European Space Agency for Orion is continuing with significant progress being made. It is clear that international cooperation will be part of any future exploration endeavor. NASA has announced a strategy that unites scientific observation, technology development, and human spaceflight activities into a unified approach. The first step in this strategy is an asteroid retrieval mission with crew-aided sample return on Orion. The mission will use the work done in the Science Mission Directorate for asteroid detection, work done on solar electric propulsion by the Space Technology Mission Directorate, and work done on the Orion and SLS by the Human Explorations and Operations Directorate. The experiences learned from this mission will provide a critical framework for human exploration beyond low Earth orbit. This is an exciting time in human spaceflight. We've made tremendous progress in the last year, and we have solid plans for the future. I look forward to your questions. Thank you.
General Stafford. Chairman Nelson, Ranking Member Cruz, and staff members, I'm once again honored to appear before you today to discuss our nation's space program. But before we begin, I'd like to take a moment to note that probably would not be here today on this specific subject, but for the crucial work done back in 1910 by you, Mr. Chairman, as well as former Ranking Member Senator Kay Bailey Hutchison of Texas, and by the key committee staff members Ann Zulkowski and Jeff Bingham, and then the House Science Committee that was headed by Congressman Ralph Hall of Texas and his staff. It was your work in crafting the NASA Authorization Act of that year which mandated the development of the Heavy Lift Space Launch System and the Orion multi-purpose crew vehicle that has allowed us to envision a robust future for NASA and the American space program. At a time when bipartisan cooperation in Congress can be hard to find, your work stands out as a shining example what can be done when men and women of goodwill are working side by side, put aside their differences, and work together for the larger service of our country's interest. As a retired Air Force General Officer, former astronaut, and a citizen of this country, I thank you, sir. Now, 3 years later, that 2010 Act still bears directly on the issues to be directed at this hearing topics, which are of critical importance to our space program today. The choice of resources, destinations, sensible mission planning and funding to reach them, the role of the new heavy lift SLS, the Orion vehicle, in carrying out these missions. With the new technologies and systems, some of which Mr. Gerstenmaier has described, will be needed beyond SLS and Orion, in a manner in which NASA can most effectively collaborate with international and with its commercial partners. In setting and reaching national goals is certainly a broad and challenging range of issues, and I'll try to address them the best I can the time I have with the opening statement, and be pleased to respond to your questions. To put my remarks in context, I'd like to take for a moment that's back to 1991 and publish America at the Threshold, America's Space Exploration Initiative. This report was prepared by the Synthesis Group in a year-long study that was chartered by President George H.W. Bush, and I had the honor to lead.
Our charter was to examine in some detail exactly the questions we're here to address: destinations, missions, systems, technologies, and collaboration. This was not the first such presidential chartered assessment, and it certainly wasn't the last. The vast majority have reached the fundamental same conclusions. The core of NASA, the core of international goals are critically thought out on space policy has been consistent over several decades, and among nearly all groups that have studied it. Possibly the best service I can perform for the committee today is to remind us of the fact and to summarize these core conclusions. They can serve as a useful guide for us today and in the future if we only heed them. Leadership in space for any society that can aspire to attain it is the key to leadership here on the earth and in human society for all generations to come. National leadership comes with the obligations to partners, to allies. It is nevertheless the only proper goal to which America should aspire. Strategies and policies based on this understanding of leadership have placed our nation in the role of the world's most influential country. Failure to take this influence into space, failure to lead in the development of the next human frontier will consign our nation to a backwater in which others, but not ourselves, will shape the destiny of human society for the generations to come. America's leadership, its power, and its influence in the world today was not, as some once thought, a matter of manifest destiny. It was earned for us today by our ancestors. We must earn it anew for our descendants, and we've earned it, and we must learn it in many ways and places. And one of those certainly, sir, is in space. Thank you, and I'll be honored to answer any questions.
Thank you, General. Mr. Cook?
Chairman Nelson and Senator Cruz, I want to thank you for your continued support for the NASA Space Launch System and many exploration programs, and for conducting this hearing into the challenges and opportunities for human space exploration. Particularly your focus on the synergy between government and the commercial sector, focusing on how a stable, long-term national exploration strategy can provide an environment for commercial ventures to thrive. The timing could not be more critical. The ramifications of the decisions you make could impact space exploration for the rest of this century. Since 2009, I have had the pleasure and honor of serving as the Director of Space Technologies at Dynetics Incorporated, a 38-year-old employee-owned business in Huntsville, Alabama, with 1,400 employees. Prior to my private sector career, I spent almost 20 years at NASA. From 2005 until 2009, I served as manager of the Ares projects, the predecessor to the SLS, at NASA's Marshall Space Flight Center. Previously, I spent several years in the 1990s with the DCXA and X-33 flight demonstrators, which were early attempts to move towards commercial-backed space transportation. Unfortunately, the fissures that have developed within the space community over the past 4 years have too often pitted the commercial and government space sectors against each other in an us versus them debate. This is very unfortunate and counterproductive. Historically, successful government-backed exploration efforts have been linked inextricably with commerce. Government-private sector partnerships have literally expanded the human footprint. At its core, commercial means that the private sector bears the burden of the investment, the resultant risk, as well as the subsequent reward. This principle has been a standard of U.S. economic growth since our founding. Private companies can be profitable by providing products and services and by creating new wealth. However, commercial successes need not be limited to the commercial sector. Partnerships between government and industry can produce valuable products that can benefit the space sector as a whole. The current landscape is rife with recent success stories. Some that I have some personal examples with are Dynetics' first commercial satellite, FastSat, is a culmination of a public-private partnership between Dynetics and NASA Marshall. Dynetics invested its own money, supplying the vast majority of the capital for the program, while NASA supported the project on a cost-reimbursable basis in terms of the conceptual idea, engineering capabilities, and facilities. The result? A spacecraft ready in 16 months that met rigorous government flight standards. FastSat successfully operated for 24 months, 100% past its design life. Additionally, private industry can take systems developed under contract to NASA and leverage these for other purposes. This has been done successfully in aerospace projects for decades. Recently, in a full and open competitive process, NASA selected several SLS Advanced Booster Risk Reduction projects. Dynetics has partnered with Pratt & Whitney Rocketdyne in developing a liquid booster concept based on the Apollo Saturn V's F1 main engine. Our team is taking a flight-proven design originally developed by NASA and is merging it with the best of modern commercial manufacturing techniques. In addition, we have an agreement with NASA Marshall which allows us to engage experts in propulsion, test, and manufacturing and utilize tooling on a cost-reimbursable basis. It's a win-win. Dynetics is pleased to support NASA and looks forward to the next phase of the competitive process slated for 2015. The bottom line is this: when we keep things simple using models proven in other markets over time, the commercial sector and the U.S. government can work together in harmony, not against one another. For this public-private partnership to succeed, a stable space policy is necessary, a space policy that transcends election cycles. A major policy and program shift now, away from the core principles of the 2010 NASA Authorization Act, will be very damaging to U.S. leadership in space. A consistent long-term policy will allow both government and commercial and government efforts to thrive. Laying out clear goals, destinations, and dates will provide an environment in which the market can and will respond. In closing, we must recognize the need to work together as a community and realize that, as in many other exploration efforts, commerce and exploration go hand in hand. Let's focus on the power of the and versus the tyranny of the or. In doing so, we must recognize that the U.S. government plays a vital role in undertaking projects that have no business case, high risk, high capital, and long payoff endeavors. And we must recognize that commercial means that the private sector bears the burden of the investment and the risk. Thank you for the opportunity to testify today. I am excited and optimistic about the future, and I look forward to enabling it for generations to come. I'll be happy to answer any questions you have.
Senator Cruz.
Thank you, Mr. Chairman, and thank you again to each of the witnesses today at this hearing. Mr. Gerstenmaier, I'd like to start with you. There has been much discussion recently about the asteroid rendezvous and retrieval mission. And I would like to ask you to share what NASA sees as the specific benefits of successfully accomplishing that mission, and also what you see as the most significant obstacles to successfully accomplishing that mission.
I think in terms of the benefits of the mission, like I described in my oral remarks and said in my written testimony, this mission brings together some activities we were already doing. The Science Mission Director was off busily looking for potentially hazardous objects that could impact the Earth. They were off surveying those. We'll expand that to now look for smaller objects that could be part of this mission that we described. We were also off looking at a demonstration flight to develop solar electric propulsion. That is needed if we're going to go the distances to Mars with cargo and crew eventually in that kind of time frame. So again, that brings in that solar electric propulsion activity that was going to occur. It also gives us a very good destination for the Orion capsule and the SLS vehicle. It can reach this deep retrograde orbit where we would place this object to be examined. It also gives us a tremendous amount of experience in operating in deep space. You know, we'll be out in the vicinity of the moon, roughly 9 days away from return back to the Earth, and that's very different than where we are today on Space Station, just several hours away. So learning to operate with crews in those regions, in those distant regions, learning how to do the orbital mechanics, dynamics, all those things really brings together all these aspects, the Science Mission Director's activities, the Space Technology Director activities, and my Director's activities all together in a unified mission that really builds us a capability that will be critical for us to move forward. So that's really the advantage I see of this mission. I think the challenges of the mission will be finding a suitable target to return. You know, it's sometimes talked about that it's talked loosely that the target is drugged back to this orbit. It's not really drugged back. It's actually returning naturally to the Earth-Moon system. We'll deflect it using the gravity of the Moon and the gravity of the Earth into this stable orbit for examination. So it's not going to be easy to find this target. We believe there are many targets of this size, but we've not really looked at this smaller diameter targets or smaller targets. So I think it'll be a challenge to find the target. It'll be a challenge to capture this target or attach the spacecraft to it. But I think it will drive technology, it will drive capabilities, it will be critical for us if we're really going to go beyond low Earth orbit with humans, and we're going to continue to explore space the way we've intended.
Now, as I have been educated by our learned chairman, my understanding is that the mission contemplates bringing an asteroid back into orbit of the Earth in what would not be a more typical elliptical pattern, but rather a more irregular orbit. Is that, do I understand that correctly? And if so, could you explain that a little bit?
Yeah, actually, the idea is to return the object to a deep retrograde orbit, which in a reference frame of rotating with the moon, it looks like it orbits the moon. It's 75,000 kilometers off of the moon, but if you look at it in more of an inertial frame, you'll see the object kind of wander between the moon and the Earth, and it looks like a kind of a little loop that I think probably you saw. What that is that's the interaction of the gravity of the moon with the gravity of the Earth that effectively keeps this object trapped in that orbit around the moon. So I think the simplest way is to think of it as in stable orbit around the moon, but then if you change reference frames, it looks like a little curlicue kind of around the Earth and the moon in that direction. But the orbit is unique in the fact that it's stable, and it's also exciting because we can get there with the early versions of the SLS and with the Orion, so we don't have to alter any of the plans we had for either Orion or SLS to go to this region.
You know, one of the important roles I think that this subcommittee can play is helping NASA articulate the benefits of the space program to our nation. And I would be curious how you would articulate to the man on the street why he or she should care about going and getting an asteroid.
I think one obvious thing to think about is, you know, we've recently had the 15-meter asteroid impact the Earth over Russia. For us to gain experience in understanding asteroids and surveying even the smaller ones, I think can bring real benefit to folks here on the Earth. Also, the techniques we'll use of flying around and attaching a spacecraft to this object, those activities will have, again, direct application to helping to protect the planet. They're not, 100% compatible for what you would do for a 100,000 kilometer size object compared to this little 7-meter object, but many of the techniques are similar. Many of the experience we gain could be very important as we try to protect our planet from these objects that are clearly in an orbit that could come back and impact the Earth. So I think the benefit is you get a chance for us to actually understand better what objects are in the environment, not just the big ones, but also the smaller ones, and then ultimately you develop some techniques that can help protect the planet from these objects if they were to approach the Earth.
And if I could ask a final question to General Stafford. You have spoken about the benefits, in your opinion, of another manned flight to the moon. I would welcome if you could share with the committee what you would see of the benefits of another manned flight to the moon and the relative benefits of that mission compared to the asteroid rendezvous and retrieval, to the extent one or the other is seen as mutually exclusive.
Thank you, Senator Cruz. Well, it's not either or. Thank you, Senator Cruz. To me, it's not an either or. When you develop the SLS and the Orion, and the support structure for this, from the control center at Houston, from the launch centers to Cape, you developed a capability. And the asteroid mission is a mission. It is not the total. And in most of the studies that I have participated in, and what we now have learned from the Russians, what they're looking at their long-term plan, that the final goal is at least an expedition to Mars. But from that, you learn on the moon. And I headed this group for nearly a year to study that. There's a whole book on it. and what we learned from that, and the operational procedures and the hardware it takes to do this. There's a reason, a lot of reasons. As I started out, the charge that I had from Vice President Quayle and President Bush Sr. was to give them the technology priorities and the architectures of how we do it. Approximately 4 months into the studies, it became obvious to us that we should say not only how do you do this, sir, but why do you do this? Why do you go back to the moon? In fact, we had a senior steering group that asked us, we've been to the moon, why don't we just go to Mars and do that? And so we dug into this. And it's very detailed, and the book is still regarded as some as a Bible as far as space exploration beyond LEO. And it tells what you can do, and also it prepares you to go further out. But in providing this infrastructure, you have this. And again, when we talk about commercial, I can say this, that NASA itself has never built any hardware. Just like in the Air Force, where I was Deputy Chief of Staff, when I had research, development, and acquisition, the Air Force has never built a piece of hardware. We have done research in cooperation, but it's all been the commercial sectors that build it. But to me, there are many reasons that the moon is the next goal, prepare and operations, and also it will do a lot of things in inspiring generations. And on that, on our recent visit to Russia last year, in the advisory task force to the ISS that I chair, pro bono work there, with about 6 or 8 other people, we have a Russian counterparts from Roscosmos. They laid out to us, I think we're the first Americans to see us, their proposed start of their next 20 to 30 years of human spaceflight. It's working its way up through the Russian government for approvals or modification. And in that, I thought it was very important, Senator Cruz, that they said they would propose the same framework that the International Space Station is managed by, with the partners. We have it. It is working good. It is a shining light to the world of how people can work internationally. And this is what the Russians would propose. In that, they showed us that they would use the SLS Orion. They'd use their new Angara, their hardware, the Ariane, and that. So it's a unifying portion, but there's a lot of reasons as to why. But the main reason, finally, and I think never every administration has said, yes, someday we should have an expedition to Mars. Thank you, sir.
Thank you, General. Thank you, Mr. Chairman.
Well, thank you, Senator Cruz. Mr. Cook, pick up on that. We've got this plan with SLS and Orion. Prior to that, a robotic mission to capture and bring into this retrograde orbit. We learned from that. Perhaps we go back to the moon's surface. We learned from that as we are getting prepared for the 2030s to take humans all the way to Mars, to take cargo to Mars that could precede the humans. And tell about how this is going to be a new opportunity for commercial involvement.
Well, Senator, that's an outstanding question. If you look at the opportunities that are in space, I think we have too often thought of space as a very niche place. Where only very few people can go at this point in the game. I think we have to change the game and look at it as a marketplace, much as the way Thomas Jefferson looked across the United States and what the potential economically would be for the nation some 250 years ago. So if we look at it in that context, and you look at something such as an outpost on the moon, following up on what General Stafford mentioned, not only would an outpost like that be an opportunity for new wealth creation, mining of minerals that have been placed on the moon and then even on asteroids later on for thousands of years that could be mined for various uses, helium-3, for example, for energy production, which I know you're familiar with, is one option. But as well, it is an opportunity for routine resupply of crew and cargo, much as what's going on with the International Space Station now, where it becomes a marketplace. You will need tens and eventually hundreds of tons of cargo initially, and then crew later. that would have to supply outposts of these types. And that is a perfect market for a place for the commercial sector to get involved and to make investments. But I think the key there is there has to be a long-term plan. There has to be dates associated with that long-term plan. And when there are commitments, then the private sector will be willing to lay out business plans and business cases to be able to go and move forward. I think that's a key piece of this in terms of how we move forward with the exploration. I think there is, again, new wealth creation, logistics support. I mean, really, it's almost endless. The key is that long-term plan with those dates that allow us in the commercial sector to leverage that and look for ways to be profitable.
And General Stafford, you were talking about international cooperation in the commercial development of these capabilities. Do you want to expand on that?
Well, the experience I had, besides my first international effort, was Apollo-Soyuz, but then as the Air Force Deputy Chief of Staff, I was the manager, configuration manager, probably one of the largest international cooperations for defense, and that was production of the F-16. And that was well over a $100 billion program in which we had Norway, Denmark, Belgium, the Netherlands co-producing the airplane that was built in Texas by General Dynamics to start with. And we continued on from that, but it was commercial entities in those countries. So that was from the DOD side. And then from the Russian side, what they proposed and what we're doing today, and that, again, it is commercial in that all the manufacturing is done by the commercial entities. Now, then the market, as far as supplying, is what has been described here by both Mr. Gerstenmaier and Cook as supplying to the station. But the marketplace today is the United States government and the partners that are on board there. But I've had experience both in the Department of Defense and also now in working there with the Russians on this.
Mr. Gerstenmaier, recently NASA has said that the SLS is ahead of schedule. What has NASA done to make the SLS so different?
I'm not sure the SLS is ahead of schedule. I would say we're on schedule. But we're moving out pretty well with all our contract activities. You know, we picked the rocket design to be consistent with the budget environment we were in. For example, we used the shuttle main engines as the primary propulsion system on that rocket, so we didn't have to go do development initially for those liquid rocket engines. Also, the solid rocket motors on the side, those came again from the previous programs and have basis back in the shuttle heritage, so we don't have to do any more qualification firings of those or any more developmental firings for those. We need to do 2 more qualification tests. So we're able to leverage off of a lot of our experience we've had before with the hardware design and rocket design to keep us moving forward. So I believe the SLS is on track. It's still not easy. The equipment, the welding equipment is starting to show up down in New Orleans now and get assembled. We're starting to begin kind of the first series of welds to make sure all that happens. The design work is getting done. The wind tunnel work is getting done. All that's been completed. There's not any big problems or showstoppers with all that, but there's still a lot of work in front of the teams. But they're very motivated. They're moving forward, and we're making solid progress towards the 2017 timeframe.
As with the authorization bill, it was to utilize a lot of the technology that we had already developed. What are some of the gaps technology gaps that NASA and its partners have to overcome to operate in cislunar space?
Yeah, there's a variety of kind of things we need to look at in cislunar spaces. As I described, when we operate in this vicinity around the moon, you know, we're now days away from safe return. So our vehicle needs to be, fully redundant, fully capable of taking failures and still keeping the crew safe. We need to make sure we have the right medical provisions for the crew, that they can be in that condition for 9 days without any ability to get back to the Earth or to get to any kind of medical care. Those are different ways of operating. You know, we've typically always been able to have an abort mode or an easy way to get back. It's going to be a different way for us to operate in that region. We also need to deal with the radiation environment of space. Again, we can deal with it for the short durations around the moon on these 22-day missions or so, but then as we start venturing out into space, we're going to need to get some more shielding, look at some water to potentially shield, maybe some spacecraft designs to shield. So there's some work that needs to be done there. And also the humans, we're learning a lot on space station, how the human body thrives or lives or survives in space in the extended microgravity conditions. This one-year increment with our Cruz we plan in 2015 will be a really important demonstration to see how well the human body really performs. The Russians have flown in space for over a year before, so it's not brand new territory for us, but they've not flown with all the detailed instrumentation and all the detailed medical exams that we'll get during that increment, and that'll really show us, is the human body really ready to go for these extended durations? So we have lots of things to learn, both spacecraft-wise, human vehicle-wise, et cetera, as we move forward.
Thank you, Mr. Chairman. Mr. Cook, you talked some about the potential for additional commercial involvement in human exploration beyond low Earth orbit. Could you elaborate on what you see as the potential opportunities both in the near term and in the longer term?
Senator, thank you very much for the question. That's a good question. And again, from the standpoint, I think you look at it in two categories. One is in new wealth creation. This is probably more of the longer term. You have efforts out there today that are looking at mining asteroids. Planetary Resources, for example, has plans to do that. Also, there's a venture out there called B612 that is looking at asteroid detection, things of that nature. Recently, NASA signed a Space Act agreement with Bigelow Aerospace to look at the broader set of implications for what does the commercial marketplace look at beyond low Earth orbit. And I think that's in a two-phase gated approach. The results of that, I think, are going to be very interesting in terms of what comes. But I think for new wealth creation in particular, whether it be new space stations in low Earth orbit, which is probably nearer term, and there are plans that are in place for that now, as well as longer term, again, an outpost on the lunar surface, for example, could be used for mining purposes. You're going to have logistics servicing of that outpost, and so those go hand in hand. The key to that, again, is having a consistent long-term plan in terms of how you want to put a lot together.
One thing you have referred to several times is potential opportunities for mining. I think it would be helpful if you could share our best knowledge and predictions as to what the mining opportunities might be, either on asteroids or on the moon itself.
Yeah, there is and I would certainly be willing to take some more, Senator, some more time and respond to that more fully. And for the record, there are quite a few studies out there, but in particular, two minerals that have been talked about the most. Helium-3, that is in abundance on the moon, that has potential application to fusion power here back on Earth, very clean power. The key there is there has to be a low-cost infrastructure. You've got to have the interstate highway system, if you will, between here and the moon to be able to get it back and forth. That's where things like SLS comes into play, that's the government-private sector involvement to be able to bring those, get the resources there to mine it and then bring them home, for example. And there's been a lot of work done on that by the University of Wisconsin, as a matter of fact. And then platinum has come up as which is obviously a very valuable mineral that could be used back here on Earth. Those are just two examples.
Thank you. Mr. Gerstenmaier, if Congress were to enact legislation that specified a specific major long-range goal for human exploration, say a lunar base on the moon or a human landing on Mars, how long would it take for NASA to develop the specific description of the component elements that would be needed to meet such an objective?
You know, when we look at both of those objectives you just described, I would say the SLS that we're putting together, the heavy lift launch vehicle, it is designed to meet both of those objectives. It comes initially at a 70 metric ton to low Earth orbit capability, eventually grows to 130 metric ton capability to low Earth orbit. That's the kind of heavy lift capability we believe to get to Mars kind of destinations. The Orion capsule is also, again, sized for that mission. It's more than a capsule. It also provides a life support capability or kind of an emergency backup. It'll have to be teamed with a habitation module if you're going to go extended durations in space. But if there's a problem with the habitation module, Orion has enough redundancy, enough space inside that it could be a safe haven for the crew for a period of time. So that's why it's bigger than a typical capsule. So I think those two pieces are part of the infrastructure. We could lay out the other pieces of infrastructure we need. We need some of these operational techniques I described to you that would come from the asteroid mission. You can lay those in, put those in place. You know, Mars is a huge step for us in terms of distance, radiation exposure, exposure of the crews to microgravity. Just the sheer magnitude of that activity is going to take some time for us to prepare. We've conceptually said 2030s sometime is the appropriate time for Mars, but we can only do that with sufficient funding and moving forward. But we've got those first pieces of that activity already in place with SLS and Orion. So I believe we're starting to put together that capability. We'll continue to add to it as we go forward. This asteroid mission fits in that same scenario. It also adds to that capability and eventually achieves those kind of goals that you just described.
Thank you, Mr. Gerstenmaier. My final question I'd like to address to General Stafford. You are someone who has spent a lifetime in public service serving your nation, and you have been involved with space since really the dawn of the space age. I would like to give you an opportunity to respond to the same question that I asked Mr. Gerstenmaier in the first round, which is, if you were talking to a man on the street, a young man, a young woman today, and that individual asked, why should I care? What difference does any of this make to my life? How would you answer that question to the man or woman on the street?
Right, Senator. Let me start from the macro and work down to the micro. You know, recently, in the last few days, unfortunately, we lost one of the great journalists of America, Mr. Alan Newhart, who the chairman knew very well. And he started Florida Today, and then against all odds, he started a national newspaper, which you can now read internationally. And Newhart traveled throughout the United States consistently, and he would still, at his age nearly 90, write a weekly column. And he had a pulse of the American people. And he stated, it was in a special edition that they made for him, that to be number one on the earth, you also have to be number one in the space. So from that, you need leadership. And leadership will take then with partnerships and that. To go down more in specific terms, it talks about the inspiration that he gives to the younger people. That is I think one of the great things that came out of Apollo, besides the infrastructure we left there that you see at the Cape with the VAB and the pads and the knowledge of how we do this. The main thing is what does it inspire you to go forward? And to me, it's an inspiration in education. You say, sure, you can do inspiration in education with other means. But to me, the inspiration, the education, and the leadership and working with the other people is the main thing. And I wish I had time, sir, to go into what we worked on for that year to describe why we should go back there besides how we should do that. But one thing I'd like to point out, with the infrastructure that's there now for most of the facilities, and the heavy lift that the 2010 Act puts forward, and that type of vehicle, the SLS, will put in, and again, they said 130 metric tons, Senator. They said that was a minimum, that they were a floor, not the ceiling. And when the booster I commanded to the moon shut off in low Earth orbit before we kicked out to the moon, we had 300,000 pounds. And today, the heaviest lift launch vehicle available is a Delta IV that has 50,000 pounds. Now, at times, some people will say, well, let's take it with a bunch of small ones and put them together. I'm sure you or your staff have had people come by and say that. But it's just not possible because you'd have to build, completely assemble, launch, check out. And then way before that, let's go back nearly 50 years. And the senior people at NASA, after President Kennedy said, we'll go to the moon and return. I like the word return, sir. It was decided that all the upper stages will have as fuel liquid hydrogen because of the great impulse it gives us. And that was what was the key to the Saturn V. And today, the Air Force expendable launch vehicles, the upper stages are all liquid hydrogen. And it gives a specific impulse in a measure of about 450 seconds versus hydrocarbons, which are good for the first stage, maybe 300. And now solid rocket motors are getting up near that 300 seconds. But you need the hydrogen to go out there. There's also a problem, and that is because of the temperature minus 423 degrees, or in oxygen, the 290-some minus, it boils, and it tends to boil off. Like, I think the best thermal protection we have, we might get 1% or 0.5% a day boil off. So you see where that leaves you. So there's a lot of challenges for Mr. Gerstenmaier and the team to cook, to work on. But that was the heritage of Apollo that we left, as to how do we get the propellants, the facilities, and everything to go there, and how we should do it. There's also another thing, and Senator Nelson and Minority Leader Hutchison put forth this bill. When you have this large SLS, you have a large diameter volume in there that you can carry a payload. When you have these small diameter rockets that people say they could put together, you do not have the volume for the payload. You just can't go and bolt them together, and you're also working against the boil off all the time. So I'm sure you probably have had people come by and talk to you, or your staff has on that. I just wanted to put that out there. But back about the main thing is the inspiration to the younger people, and I'll be glad to provide your staff with one of those books. And all right. Thank you, Senator.
Very good. Thank you, General. Thank you, gentlemen. Thank you, Mr. Chairman.
Thank you, Senator Cruz. General Stafford, on that point, share with us, since you were a part of the Apollo program, the generation of scientists and technicians and mathematicians that the early space program spawned.
Well, Mr. Chairman, it's amazing today when in talking to people, I get recognized, or people I get introduced to. So many people have said the reason that I studied to be an engineer, I studied to be a doctor or something, was because I saw what you did in Gemini, what you did in Apollo, and that inspired me. Yes, I wanted to be an astronaut. I realized the chances are very small, but that still inspired me. That's why I wanted to be there. So I think there's been such a tremendous fallout from that helped make our country forward. And you see where we stand. We still have the best research development in the world in this country. And this technology is what makes this country great. When we lose that inspiration to go forward and have this technology, then we have lost a lot.
Now, let's go from the heights of inspiration to the depths of reality. Mr. Gerstenmaier, what happens if sequestration across the board continues and affects the NASA budget in 2014 and beyond?
Well, simply, we can't deliver the programs that we've committed to you we would deliver. We can tolerate the 13 sequester activity that occurred to us because we're prepared, but if it continues into 14, the programs I described, the timetables I described to you, I don't believe we can continue to support it at the levels we did. So this is really going to be tough for us moving forward.
And are you in a position, from your platform of the 2013 budget and what you project into the future, are you in a position to really encourage the private sector to get involved and develop these space exploration technologies that are advanced.
Yes, I think, again, the President's budget that was just submitted or just released that you've seen for 14 and out, that keeps these programs moving forward and includes some technology development. It also involves us working with the private sector to continue to move forward. You know, we've done a lot in the cargo and crew world, but I think there's even more we can do in other areas. So we'll continue to look to the private sector to partner with them to move forward. I think as Mr. Cook said, it's really the partnership between the government and the private sector needs to be there. We need to use each other, use the best of both activities to figure out a way to work jointly together and move forward. And I think that's key to us moving forward. So as we talked in this hearing, I think international is important to us, and then private-public partnership is also tremendously important to us.
General Stafford, when we were in the great space race to beat the Soviets to the moon, they tried. They had this big rocket, and that big rocket blew up. Tell about that, and tell what happened there, and tell about the derivatives of that rocket, how they are actually using it in the commercial sector today.
Mr. Chairman, I'd be glad to do to my best of my knowledge. And when we made the commitment to go to the moon, the Soviet Union at the same time made the commitment to go too. But again, one of the keys we made, as I mentioned, was a decision to go to liquid hydrogen in those upper stages and with large thrust engines, which we'd never done before, and also the first stage. And building a large rocket engine is a very difficult task. The bigger you get, the more they tend to go unstable and explode. In fact, when I was flying in the Gemini missions, the F-1 engines we had on the giant Saturn was still exploding on the test stands, which is not too much of a comforting feeling. But over a period of time, they worked out the right form of the injectors and worked that out. That's one thing the Soviets never could work out, was to build a large single-chamber engine. And you even see it back into the Soyuz rockets they're flying. You see all those nozzles. It's really one engine, but 4 barrels. And then on their RD-170, which had as much power as our F-1, they could not get a stable combustion, so they went to 4 different barrels. Now, on the large N-1, which was bigger than our Saturn V, it had nearly 10 million pounds of thrust, but instead they had 30 engines on the first stage. I would term it a plumbing nightmare. And I talked to my dear friend General Leonov, and he watched the first one started up and then exploded and blew pieces about 10 kilometers away. And they did not have the technology as far as the gimbals on it. And so they were going to change attitude by throttling the engines, which was not a bright thing to do. And they were going to use kerosene and liquid oxygen in all their stages, which had the far lower impulse. So even though the booster had nearly 10 million pounds of thrust and weighed more than the Saturn V, it did not have near the payload to get out there. And they had too much complexity in that. Now, the engines, those 30 engines they had on the first stage was called the NK-33. They've now been taken by Aerojet and modernized and called the Aerojet 26. And they put gimbals on them, rechecked them, and it just recently flew perfectly on this flight by Orbital Sciences, which will develop go on their booster, which will go to supply cargo to the space station. So those are 45-year-old engines, but they've been modernized and evidently work perfectly, sir.
Mr. Gerstenmaier, space station, it's doing well with a crew up there working on science. How about telling us, do y'all have any feeling about, since we extended in law its life to 2020, what about extending it beyond 2020?
You know, our discussions with some of the commercial groups, and you could probably talk to the Center for Advancement of Science and Space, the CASIS organization. You know, their feeling is that if they knew station was going to be around beyond 2020, there might be a different market on the commercial side that would be interested in using station. So I think we're starting to hear the kind of the groundswell from outside users and other folks that station is proving to be a very vital asset. It's things that they're like to do research there. We're starting to see a lot of Earth observation payloads go to space station in the next couple of years. And I think if the horizon for space station was extended, the market might actually get a little bit larger. But I think it would be worth a good discussion with the private sector about what they think about that and if they saw a bigger market if station got extended and moved forward. But I'm starting to hear general indications from the user community that extending the life of space station would be a very good thing.
Can you speak as to some of the vaccines that are being developed now and being tested?
Yeah, there's not actual vaccine work being done, but it's more kind of genetic or generic research being done on station. The two big areas of interest are immune system degradation, which occurs in our crews on board station. Their immune systems are not dysfunctional in space for some reason. That proves an interesting way to test potentially new drugs that affect the immune system. We're going to have the ability to take rodents to space here next year on space station, and they can be used as a test medium for potentially new drugs that are being developed on the ground. And before a pharmaceutical company wants to take those into final FDA trials, they could actually do a very simple experiment to see if this candidate drug is effective in the immune system and preventing the immune system from becoming less effective. So there's some work going on in that area. We also see gene expression in space is very different. That allows some innovative ways to go look at things such as we've talked before about the salmonella vaccine that can be then developed based on indications of the variations in genes from samples that were flown to station. So there's quite a bit of interest in the pharmaceutical area along these lines in both the potentially dealing with bacteria and the change in the genes that occur in space, and then also on the immune side. So both of those are very promising areas that have real application to folks here on the Earth. This is another way of getting insight into potential new drugs and their effectivity, and we can do it in a fairly quick manner by using space to do that.
Did you say that the human immune system works better in space or less better?
Less better. It doesn't work as well.
And how about the vaccine for MRSA?
Again, it can also benefit potentially from this same gene expression thing. We can get a chance to go look at different ways that genes are expressed, and then that can potentially lead to potentially some type of drug that can help with MRSA. So again, it's giving us, what happens in microgravity is it gives us a unique insight into the way the bacteria and genes express differently in space than they do here on the ground, and that unique change can then let the researcher develop new techniques or new ways to protect against the particular diseases that are there. And there's a whole variety of them. MRSA is one. Any bacteria in space, a new novel way of trying to protect against it can be developed from research in space.
I want to ask you, what are the other missions and destinations that are necessary as we get ready for a long-distance mission to Mars?
Again, I think space station can be kind of that first step. We can gain a lot about how the human performs for long-duration exposure to microgravity, so that's an important thing. Station is also a good test bed to go look at life support systems, the systems that generate oxygen, remove carbon dioxide, reprocess water. Those systems on station can be run for extended durations, and we can develop a low-maintenance system that doesn't require a lot of maintenance. It doesn't require a lot of hardware to keep it operating on station, and we can prove that system essentially on station. So that long-duration life support system that will be necessary to keep our crews alive on journeys to Mars, that can be tested on board space station. In fact, our next generation of life support systems on station we intend it to be the exploration systems that will fly in the future. So station is giving us a unique chance to experiment with technologies that we're going to need to go into the long duration flights to distances such as Mars.
And describe how the station will serve as a platform to develop the propulsion technologies to go to Mars.
Again, station is a good platform to check things out. We've been looking at potentially installing some small thrusters on station. We're not sure we're going to do this or not. They could look at drag makeup, but again, it could be essentially a test facility for those small thrusters. You know, we're also seeing in the same vein, we're seeing a lot of instruments that people would like to add to their spacecraft. They can take those again to space station. They can check those instruments out on space station, and then they can add them later to their spacecraft. So station is proving to be a very interesting proving ground. You'll see in the next coming years some things fly that are flying on dedicated satellites. For example, the carbon observatory that's going to fly as a dedicated spacecraft. There will be a companion set of instruments that are essentially the spare instruments from that spacecraft. Those will fly to space station. They'll be attached to space station. And they will also give us insight into carbon generation on the Earth. What's interesting is a satellite flies in a sun-synchronous orbit, so it looks at carbon generation at essentially the same solar time every day. So you see carbon generation at one point of the day. That's a very good standard. That's understood. You can look at carbon generation on the Earth from that. But then station, because it flies in a different orbit, it looks at those same locations but at different times of day. So that's going to give the researchers some insight into carbon generation throughout the day. So it gives them a different look at the same phenomena that they're doing with their dedicated spacecraft. So there's a nice synergy between the dedicated spacecraft that takes science in a more pristine, more organized manner. Then there's the space station, because of its orbit, that picks up data in a little more random fashion that adds to that data and actually builds a better combined data set than individually. So you'll see that fly. There's an aerosol experiment that will also fly, and then there's a rapid scat which looks at winds in front of hurricanes also. So there's a whole variety of uses of station that are starting to come about.
Well, you've just made the case, if we're going to Mars in 2030s, of why the space station ought to have the life beyond 2020. It's legal life now in law. And Mr. Cook, we'll let you be the cleanup hitter. Tell us if you've got an extended life of the station, what does the private sector think of in the development and use of the properties of the station in order to benefit the private sector?
Thank you, Senator. I think Mr. Gerstenmaier has laid out, for example, vaccines, new things that could be manufactured in space, new vaccines, new materials, things of that nature. But I want to flip it around the other way, and there are some technologies that to expand the marketplace of terrestrial companies today. For example, one of the experiments that's being ready to be flown on the International Space Station is an additive manufacturing experiment where you can literally grow parts in space. You can grow items in space. And there are printing technologies that allow you to do that today that are commercially available now. And this allows for a whole new market for them to be able to then take it to the space station and test it out and demonstrate it out. Build prototypes of parts, build even some parts in terms of and how does that work in space? Does it work as well as it does on the ground? It's another market. There's technologies that we're involved with in terms of taking commercial nanotechnology, being able to grow tools and other systems from pretty much any metal or any combination of metal and ceramics in space. And so you use the space station as the ability. It's compared to Mars, getting logistics up and back to the space station is fairly straightforward. Once we go to Mars or anywhere else beyond low Earth orbit, we've got to be able to live off the land. And so using the space station as a platform for companies that have technologies that work here on Earth to expand there into space, I think additive manufacturing is one very exciting area that a longer-term space station would allow that to be fleshed out over time.
And Mr. Gerstenmaier, I keep saying the final question, but we've been joined by the esteemed senator from Connecticut. Explain either the space station or the retrograde orbit of if you can park things there or have things on the station, as you develop the technologies to go to Mars, that you don't have to go back down onto the surface of Earth to resupply. Give us some of your thoughts there.
Yeah, this asteroid retrieval mission that we described in this deep retrograde orbit, that's an interesting region of space. Some of the things we could do there potentially are Mars sample return we've talked about. We could use a similar technique to return a sample from Mars to this region. Once it's in this region, it's stable for an extended period of time, probably multiple decades. So therefore, we could pick up Mars samples from this region. Some of the Lagrangian points are interesting gravity locations around the moon. Potentially maneuvering from those to deep space destinations is interesting and intriguing to us. We need to learn more about these regions and how we can use essentially the gravity of planets, both and also the moon, to assist us in going to these various destinations throughout the universe.
So you could bring a Mars sample back, park it in the retrograde orbit, and go sample it whenever you want to, because it would be stable. We'd have access to get to it. You wouldn't have to work on it by taking it all the way back to Earth and then coming out of Earth back into orbit.
That's correct, especially the asteroid. If it was there, one visit probably doesn't give you enough information as you'd want. Steve talked about some of the potential minerals and things on the asteroid. You could actually spend several visits there to go look at it, characterize it, understand, are asteroids really a viable source of material for missions into space. So again, it gives you the advantage of having this object in a location where it will remain for an extended period of time, and you can visit it with essentially the capabilities we have today.
Since the amount of gold on the planet would fill 2 large swimming pools, Mr. Cook, if you find an asteroid that's got gold in it, I'd say our space program would be off and running.
Yes, I think that's a fact, and I think again that's where viewing space is not just a novelty and not just a niche place, but is a marketplace that can be utilized for the benefit of mankind here and growing our economic sphere. That's the approach we need to take. That's the approach that was taken in almost every other exploration effort I can think of over history, and we ought to be considering that collaborative effort from day one.
It's just like the Spanish explorers that found Florida. They were looking for gold, but look what they found. All right, the senator from Connecticut, Senator Blumenthal.
Thank you, Mr. Chairman. On that note, I was thinking the last gold rush was by horse-drawn wagons, so we've come a long way, although our ultimate aspirations may be very similar. And I want to thank all of you for your excellent testimony, which I've been following even while I've been absent here through the wonders of our modern communication system. And also thank you to our chairman, Senator Nelson, for his leadership here on this committee. I have a somewhat more mundane area of inquiry, and I won't belabor it because I know we're near the end here. But I am interested in how NASA, as its mission changes, as new programs are developed, Constellation folded into Orion, for example, changes its contracts so as to maintain competitive bidding. In other words, I'm very interested in the openness and competitiveness of the contract awards, so that when, in effect, the mission changes, if there is a need for new services or goods, is there also a move to maintain or open new rounds of competitive bidding? I don't know who would want to answer that.
I guess I could answer that. I would say that, we have requirements for justification for other than full and open procurement, right? So there's a in the federal acquisition requirements, there's a pretty strict set of criteria we need to meet to not go compete. So our clear preference is we would go out and compete unless there's demonstrable advantage that shows it's of overwhelming advantage to the government for us to not compete. And things would be, is there substantial investment already made in a previous program that is directly applicable to the next program? Those kind of considerations. Is there not really another competitor in this field? That's another consideration. So we logically have to go through all those various constraints, understand those, and then if we show that there really is no advantage to competition, then we could potentially award through the justification for other than full and open procurement to one of the existing companies. And we did that when Constellation went away. We went through each one of the major components. We looked at what was justifiable, where was a significant advantage for us to continue the existing contract, or we went out and competed some of those contracts. And our experience shows we've made tremendous progress in SLS, and some of that is because we realized exactly what we said in the procurement time frame. For example, on the core booster, we argued that the upper stage for the Constellation program was almost identical to the core stage in manufacturing, so we did not compete that particular contract. And we were able to make tremendous advantage in that activity, as evidence where we are. We're a little bit over 2 years away from when we did that initial transition, and we're already in the process of being ready to manufacture hardware next year. So that shows how fast we were able to turn around, and that was justifiable and evidenced by the actual performance. But our preference is clearly to do competition and to open it up. I'm continually surprised by what the market can provide. I think competition is extremely healthy for us, and we need to look for competition wherever we can.
What would be some examples or an example of what you decided to compete as compared to the instance you just mentioned where you decided not to compete it?
I'm trying to think through some of the I would say for the cargo systems that we're using on Space Station, when we decided to pick a cargo resupply services contract, we actually put that out for full and open competition. We had an extremely good competition for that activity. We ended up selecting the two companies that are starting to deliver cargo to space now, SpaceX and the Orbital Sciences Corporation. But again, that was a pretty intense competition between all those providers. I believe we've lowered the cost of cargo to Space Station because of that competition. So that's probably an example of where competition was good and helped get us a better value for what we're trying to do. It was also interesting the way we did that procurement. Typically we would build the spacecraft or contract out for the spacecraft itself. In this case, we didn't. All we did was acquire a service. So that's another thing that's good for us is when we see there's a market and they could potentially use that rocket to lift scientific payloads and other things. There's a market beyond what our need is. In that case, just asking for the service is much better than us actually asking to have the rocket built and then us, the government, owning that rocket. So that's another thing that you'll see a lot of us doing more on is actually just looking for the service. And even the expedition flight test is going to occur next year where we're going to look at the heat shield of the Orion capsule. We did that in a unique way. Typically, we would have procured the launch vehicle. We would have integrated the Orion capsule on top. But what we did there, again, is we kind of chose that as a service contract. We want the entry heat shield data. And so we didn't specify what rocket would be used for that. We left it up to the contractor to determine what rocket. They will do the integration of the Orion on top of that rocket with us just kind of watching. So NASA's not directly involved. So again, we're looking at, I would say, an innovative way of getting a standard service that doesn't involve government ownership, but lets the market go do that. And that's another extremely effective way I think we've been able to lower some of our costs and get better value for the government.
And just one last question. Are there areas where you haven't made that decision about whether to compete it or non-compete it?
Yeah, for some of our future work sitting out in front of us, we go through an acquisition strategy meeting. And through that acquisition strategy meeting, we describe these factors I just described to you, and we figure out what the best approach is to try to acquire a service or a capability we need and what that approach ought to be. We review that with the senior leadership of the agency, and we go through a formal process to do that. So there's quite a bit of work out in front of us that still needs to be done.
And my understanding is that if I can put it in lawyer terms, not scientific terms, forgive me, that the burden of proof, in effect, is on the argument that there should be no competition. You're willing to go that route if there are clear advantages in cost or time or whatever to the United States, but otherwise you would go the compete route.
Yes, and that's what the federal acquisition rules and regulations require us to do.
Thank you. Thank you very much, Mr. Chairman.
Thank you, Senator. It's been a very good discussion. Thank you all for participating. The meeting is adjourned.